We've taken a look at scientific notation problems and changing them from scientific notation to standard notation. This video, we're going to go the other direction. And remember, if we want to end up with scientific notation, a times 10 to the b, if the b is negative, that's going to tell us we're dealing with a small number. So if I had a number like 0.000042, I know when I calculate my b, it's going to be a negative number. Similarly, if b is a positive, I know that means I'm dealing with a big number. So when I'm looking for what my b is, if I've got a number like 8,230,000,000, I know the b has to be a positive number. So how do I determine what b is? b tells us the number of times to move the decimal so a is between 1 and 10. It can be 1, it can't be 10. So we want it basically to be a single digit followed by a decimal point. So for example, if I've got 48,100,000 and I wanted to convert that to scientific notation, it's a big number, so I know the b is going to be positive. The decimal point is to the right now. To move it in front of the first digit, we go 1, 2, 3, 4, 5, 6, 7 places. So we have 4.8 times 10 to the 7th. Because it moved 7 places, we have a big number, so that exponent is positive. Also, if I've got 0.0000235, this is a small number, so I know the b is going to end up being negative. As I move the decimal point, I move it how many times? 1, 2, 3, 4, 5 to put it after the first digit. 2.35 times 10 to the 5th, but I make it a negative 5 because we were dealing with a small number. That's how we can convert back and forth between scientific notation and standard notation. It's time for you to practice some of these and let your instructor know if you have any questions.